Hey IBSL1 fans, welcome back. Today we're going to talk about 3.5, which has a lot to do with solving quadratics by using factoring. Now, you guys have all seen factoring before, but we're going to go over all the different ways you can solve things with factoring. Now, just a heads up, I'm going to use a lot of lingo in this lesson that other math teachers will have no idea what you're talking about if you use it with them. So these are just for our lessons. I use these terms. There's three types of factoring, in my opinion, for quadratics. There's baby factoring, there's simple factoring, and there's a more advanced factoring called smoke and mirrors. So, before we get to any of that, all of this kind of hinges on being able to use this thing called the zero product property. Some math teachers call it the ZPP. I just call it the zero product property, but it basically means like if you multiply things and get zero, that one or both the things has to be zero. So just a quick example of the ZPP. Let's say you had something like 2 times x minus 3 times 5x minus 2 is equal to 0. Now, you guys, if you just think about conceptually what's happening, that means that there's 3 things getting multiplied and you get 0 out of it. So how does that happen? How can you multiply numbers and get 0? Well, if you multiply numbers and get 0, then one of them has to be 0, or all of them could be 0. So anytime you get an equation down to this sort of factored form and it's equal to 0, you have to split these and say x minus 3 is equal to 0 and 5x minus 2 is equal to 0. And then solve these both simultaneously. So your answers would be x is equal to 3 and x is equal to 2/5, because you add 2 and divide by 5. So 2/5. That would be your answer for this example because of the zero product property. Now, let's solve a bunch of different quadratics using baby factoring, simple factoring, and advanced factoring, smoke and mirrors. You guys, a lot of people, I will give them an equation like this, 3m squared minus 5m equals 0. And they'll be like, Mr. Jolly, I can't solve it. There's no like plus something on the end. Don't you need like a third thing to be able to use all your quadratic tricks? And I'm like, dude, you're overthinking it too much. This is baby factoring, because before you do any type of more simple or advanced factoring, you should always see if all the terms have something in common. These two terms both have an m in common. So you would factor that m out to the front, and that would leave you with 3m minus 5 left over. Now you have two things being multiplied to get 0. So you use the zero product property and split them. So m is equal to 0 and 3m minus 5 is equal to 0. So your answers are m is equal to 0 and 5/3. Add 5, divide by 3. So that's baby factoring. You should always check if there's a common monomial. Here's the math teacher term if you want to impress other math teachers. A common monomial could be factored. I just call it baby factoring. Now, simple factoring, I'm sure you guys have seen before. You have like your classic quadratic here of x squared plus something x plus something. So what you do is you think of numbers that multiply to 6 and add to 5. So the thing, sometimes like teachers will do like a little cross off to the side and they'll be like, okay, it's got to multiply to the top number and add to the bottom number, the middle number. So then you think, well, to get 6, you could get 6 and 1 or -1 and -6, but those don't add to 5. So you could do 2 or 3 or -2 and -3. 2 and 3 are the ones that add to 5x. So I think once you have those two numbers, you can just jump straight to here. X plus 2 and x plus 3 is equal to 0. I always do a quick FOIL in my head to make sure I'm going to get back the original problem if I first outer interlast this. So you get x squared plus 3x plus 2x plus 6. So the 2x and the 3x. Yes, it does work. I did it right. Then use your zero product property to say that x plus 2 is equal to 0 and x plus 3 is equal to 0. You don't need to write out this step every time. I'm just kind of trying to be a little formal with you guys. So x is -2 and -3, both. You could always plug those back in up here to make sure you get 0 out of it, to make sure you have the right answer. Now, I thought that this was kind of weak, the x squared plus 5x plus 6, so I came up with a slightly better example, where your two numbers have to multiply to -88 and add to -3. So this is where I might grab my calculator and be like, okay, 88 is divisible by 4. So 4 and 22, but those don't get anywhere close to -3. So 88 is also divisible by 2. That's 2 and 44. That also doesn't work. So what about 88 divided by 11? 11 and 8. Oh, yes, this does work. So, you guys, because this is negative, that means that one number is going to be positive and one's going to be negative. So you could do a cross for this one and say it's got to multiply to -88 and add to -3. So I think it's like it has something to do with 11 and 8 because those have a difference of 3 between them. But then you got to decide, is the negative on the 11 or is it on the 8? Well, you need this number to be negative, so the bigger number's got to be negative. So -11 plus 8, that works. So that means it's x minus 11 and x plus 8. And I'm fine with you guys just jumping straight to the answer. It's 11 and -8. I think with those little ones, you can just see that it's like the opposite signs, so you can go straight to here. I'm cool. Now, you guys, there's this thing called advanced factoring, which I learned a long time ago from a math teacher called Smoke and Mirrors. I've never met another math teacher that uses this term, so once again, they will look at you funny if you're like, oh yeah, you just smoke and mirrors it. You guys, the reason this problem, if you're trying to factor it and solve it, that it's a good candidate for advanced factoring is this right here. The coefficient out front. Notice on all the other ones, the coefficient in front has always been a 1. Here, here. Now it's a 2. So the first thing I would check, is it baby factorable? Can I take a 2 out of everything? Well, I could take a 2 out of the -4, but I can't take it out of the 7. So no, baby factoring is not an option. That's when this is a perfect smoke and mirrors candidate. Now, when I was in high school, our teacher just gave us this and was like, oh, you just guess and check it. You just, you know the first two things have to multiply to get 2x squared, so it's got to be 2x and x, and then the back two things have to be -4, so it could be like -4 and +1, or you're not sure if it's that order, so it could be like -4 and +1 here, but also that's not the only things that multiply to -4. You could also have -1 and +4 in both orders, so you could have like -1 here and a +4 here, or you could do the +4 here and a -1 here. And then you would just have to FOIL all those to figure out what the answer is. With this one, it's actually not too bad. You probably could guess and check your way through it. But if I scroll down to my next example here, like, think of all the things that multiply to 6 and all the things that multiply to -20. Like, there's so many different combinations. Like, you might get lucky guess and checking with some combination, or you might have to check like all 16 of them before you find the right one. So I'm going to teach you the smoke and mirrors, which works every time. It's called smoke and mirrors because it's like magic. First step, you multiply the front coefficient and the back constant to get -8. Then, similar to the simple factoring, you do a cross and you pop that -8 up top, and then down below you put your middle number. So -7. Then you have to think of two numbers that multiply to -8 and add to -7. They are -8 and +1. Once you have those two numbers, -8 and +1, you are going to split this middle term. So if you take that middle term, should I color code? Let's try it. 2x squared, and then split it into -8x and +1x minus 4. So what just happened? This whole middle term is this right here, because -8x plus x is -7x, so you split it apart. You might look at that and be like, well, that's silly. You're just going to have to you know, combine those terms and you'll be right back where you started. Before you do that, the next step you do is called a double baby factor. So you're going to factor the front two and the back two separately. This is also called factoring by grouping. Oh, this is kind of a funny example. When I look just at the 2x squared and the negative 8x, they both have a 2x in common. So I pull the 2x out, and we have 2x, or x minus 4 left over. So that was the first two terms. Now, the back two terms, normally there would be some sort of common monomial that comes out of them, but sometimes you get this special case where there is no common monomial between x and negative 4. So in this case, you can actually pull a 1 out, which seems like a silly move, but one of the whole points or parts of the smoke and mirrors method is you should always get this to match this. That should happen every single time. If it's not happening, you messed up somewhere. So those x minus 4s are matchy-matchy. You can factor those out and pull them out. And then what you have left over is the positive 1 and the 2x. So this is 2x plus 1. Now it's factored. And then you do your zero product property and get x is equal to 4 and negative 1/2. All right, let's try smoke and mirrors again, but with a harder example where, because I show kids this method and they're like, that's stupid, I'm just gonna like guess and check it. And I'm like, all right, cool, but like a problem like this is probably gonna be more painful by guess and checking. First step with smoke and mirrors. Can I pull out a common monomial? 6, 19, negative 20, they have no number in common because 19 is prime. So if you take the 6 and multiply it with the negative 20, you get, what, negative 120? Then off to the side, you do a little cross, put negative 120 up top and positive 19 at the bottom. Now, this is the part that's kind of a bummer about smoke and mirrors, is you still have to do a little guess and check work to figure out two numbers that multiply to negative 120 and add to positive 19. So this is certainly when I would grab a calculator and divide negative 120 by certain things. So I'll try 4. 4 and negative 30 doesn't get me there. Negative 120 divided by 8. 8 and 15, that also doesn't get me there. What about some factors of 3 or something? 120 divided by 6. 6 and 20 doesn't get me there. What about, let's see, 5. 120 divided by 5. 5 and 24. Ooh, that does have a difference of 19. So I found it. It's 5 and 24, but one of them has to be negative. Now, since this number is positive, we know that the whole thing has to be positive. So it's going to be negative 5 and positive 24. Now we're going to split the middle coefficient into those two terms. So we get 6x squared plus 24x minus 5x minus 20. Now, you might look at these two and be like, Jolly, why did you decide to put the 24 first and the negative 5 second? The answer is, like, you don't have to do it that way. It would have worked the other way as well. But I always kind of, like, look at this term and see, like, which ones might pair up nicely to make the baby factoring easy. Because now, if I go to baby factor, 6x squared and 24x, those both have a 6x in common. So we get 6x, x plus 4. And then if I look at these guys, negative 5x and negative 20, they both have a negative 5 in common. Pulls out nicely. And we get x plus 4 left over. And then, as if by magic, this x plus 4 they have in common. That should happen every single time that you're doing smoke and mirrors correctly. So if you pull the x plus 4 out, you're left with a 6x minus 5, which came from here and here. The whole thing is still equal to 0. Then you can ZPP, get negative 4 and 5/6. Do not turn that 5/6 into a decimal. Keep it as a perfect fraction. couple more problems for you guys. Find the roots. You guys, the roots is also like a way of saying the x-intercepts, but you're not going to graph it. We're going to use algebra. Or the zeros. That's another way to say the roots. Does zeros have an E on the end? I don't know. So, you guys, if I'm going to find the roots, the x-intercepts, you're going to want to use factoring. But the first step you want to do is get everything on one side. So, I'm going to keep the 3x squared over here. Subtract 16x, but also subtract 8, so you get negative 12 is equal to 0. Now, if I give this as a test question, a lot of students will see this 3 and be like, oh, I should smoke and mirrors it. So then they multiply 3 and the negative 12, blah, blah, blah. But you guys, oh, no, wait. We do have to smoke and mirrors it because I thought the 16 was divisible by 3, but it's not. So, yeah, we got to smoke and mirrors. 3 and the negative 12 is negative 36. Two numbers that multiply to negative 36 but add to negative 16 are negative 18 and positive 2. Do your little cross off to the side. Negative 18x plus 2x minus 12. And then you double babies, so do the front and the back separately. So we get 3x, x minus 6, plus those both have a 2. X minus 6, matchy-matchy, that's supposed to happen. See the x minus 6 and the x minus 6? Dope. That means x minus 6 and 3x plus 2 are good to go. And we get x is equal to positive 6 and negative 2/3. So those are the roots. This next one is kind of weird because a lot of people would start by subtracting 11 from both sides. And you can do that, set it equal to 0, because that's like what I did up here. I got everything on one side. But if you look at this for a second, do you see how this side looks like it factors real nice? Like 5 times 5 is 25, and they add to 10. So that means you can get x plus 5. X plus 5 is equal to 11. Then x plus 5 times itself is x plus 5 squared. And then you can square root both sides. I'm going to make a mistake for you guys real quick. Boom, I made it. I square rooted both sides, jolly. What's the problem? You guys, you have to right now agree. Anytime you're going to square root both sides, you have to put a plus minus in front of it. So then you subtract 5, and our two answers are negative 5 plus root 11 and negative 5 minus root 11. You know what? I think we're going to cut it off there because this video is getting kind of long.